Woo! Hello, my name is Justin, and this is our vertical garden lab 2. Lab 2. Okay, awesome. Let us begin. So, what's the problem? So the problem is food insecurity and that it affects millions of people. 10.5% of US households lack safe, nutritious food, and 4% face severe insecurity. COVID-19 worsened the issue, especially for children, students, and oh no, vulnerable groups. California drought created limited water resources, making traditional farming unstable and unsustainable. Design goals. We must create a garden that improves nutritious food for access for students and community. Aloni. Use water-efficient methods and drought-tolerant crops. Employs environmental monitoring and smart tech, and we must stay innovative, sustainable, and creative. And I'm gonna pass the mic to my friend over here.
Yeah, so this is gonna be our plan. We will, since this is the back wall over here, we're gonna fit in 8 Ferris wheels, each separated into duos and groupings. I don't know if you can see on the screen, leafy greens and herbs are gonna be over here. They require less sunlight. Root veggies, climate-tolerant plants, and a bunch of walls are gonna be used to fit vines. The one over here is the more finicky plants. They require a special bubble where we can control conditions such as temperature, humidity, other things. Yeah, with all of this, we will be able to feed 5,000 people with the limited space we have been given because the Ferris wheels go up, so we don't have a lack of space there. This space will grow wheat, this space will grow wheat, and all of this over here, the extra area, will grow corn, beans, and squash as a sisters grouping that goes back thousands of years to Native Americans. And we will move on to background research, environmental conditions. So I will now introduce my other teammate.
Hey, my name's Jacob. Wait, I didn't do this part.
Hey! All right, so environmental conditions. So the environmental conditions of Fremont Mission Peak. It's gonna be, winter's gonna be short, cold. You can see right here the forecast is gonna be, in the winter's gonna be short, cold, and wet. High's gonna look from the 50s and 60s. Lows sometimes into the 40s. Summer, long, warm, dry, and mostly clear. Highs often in the mid 80s to 90s. A little dryness right over here. You can see nice drop to 60s, and typical temperature ranges from 43 degrees to 82 and 92 degrees. So, precipitation and water. Annual precipitation is modest, around 14 to 17 inches per year. So not that much. That's why we have to consider our water restrictions. And other conditions include humidity tends to be moderately low, a lot of sunlight, and some dew. And then I'm gonna bring it over to my friend over here. Woo, yeah.
So for plants and their grouping, we grouped the leafy greens over here because they require less sunlight. So we can fit lots of them on the Ferris wheel over there in the corner. There's not too much sunlight reaching over there, there's plenty of shade. The herbs also don't require too much sunlight, so when they rotate, there'll be more shade happening. Herbs will go over there. Root veggies will come over here. The root vegetables will include carrots, beets, radishes, and potatoes. Those are great for the California climate, especially Fremont, so we don't need to put in too many different conditions. We don't need to monitor those too much. The climate-tolerant plants, ones that also fit very well with Fremont, peppers, bush beans, and peas, strawberries, eggplant, and zucchini. The vines that go on the wall over here will include grapes, passion fruit, specifically Passiflora edulis Frederick, pole beans, which are beans that grow on poles or vines, and kiwis, which, if you didn't know, are also vines. So those will all grow over here. Wheat will be wheat. The herbs that will be growing will be mint, parsley, cilantro, and chives. The Three Sisters Guild, corn, beans, butternut squash. The finicky plants that require their own special section with a greenhouse specific to them will be cucumbers, melons, ginger, turmeric, and mushrooms. They grow in conditions not seen here in Fremont, so we'll need to monitor those more. And the leafy greens specifically will be lettuce, Swiss chard, spinach, arugula, mustard greens, and kale. So all of that should be enough to feed 5,000 people. I'll move that on over to the design sketches. This is Justin again. The plot layout.
Yeah, so I plotted this out. This is all of my work. I'm just kidding. Okay, so how we separated out was this is the big wall side. Hold on, you can see. This is the walkway. This is the door. This is the big plot of land that we have over here. She kind of already explained how we laid it out, but essentially, the Ferris wheels are going to be the little green rectangles, and then the red boxes right here are going to be the plants that are on the ground, not on the Ferris wheels. We're going to have little row bugs. We'll get back to that in a bit, and then have little green or little blue bubbles that will block off like insects, birds, stuff like that. Create a nice humid environment for every respected category of plant. All right, and I'll bring it next out to Ferris Farm design plus irrigation picture.
Yay! Hi, my name is Dante. So for the Ferris Farm design, we're going to be utilizing drip irrigation, and it'll be connected to other Ferris Farm structures with a single distribution line, and we'll use water sources such as like sinks, fountains, and everything else that contains water within the campus to carry out the water to help with the plants. And then row bugs. These we'll also cover later on more, but these are the designs. They'll help out with the farm itself, or the garden. We have two designs, one that's designed like a moth and one that's an ant. They'll manage the pH levels of the farm, gather water as a secondary source, and have camera sensors to help with dealing with pests and such. Thank you. And then next off, design explanations.
Hey, my name's Jacob. Right now I'll be explaining the layout and how the greenhouse works. The greenhouse contains kind of like three main parts. Has a dome that can change its brightness level. That works by, or the reason why we have that is so when there's different climates and stuff, and when it's too sunny or not too sunny, the greenhouse can change the darkness of the glass in order to make it so like the sun doesn't cook the plants inside, or the plants inside get enough light. The next main part is its water collection system. So like when it rains and stuff, the greenhouse has these little water collection systems like right next to it at the ground, which collects water when it rains. And then it also has a humidity system that can change the humidity of the air inside the dome. Now as for the layout, there's 6 different parts of the bigger plot. We got the leafy greens right there, the herbs, the root veggies, the climate tolerant plants, the vines, and the greenhouse plants. Then after that, we got the wheat right here, right next to the trees, because, we don't want to disrupt the trees with our greenhouse stuff. Then for a smaller part of land, we just have 3 smaller domes, with each having its own plant. And then the Ferris wheel. And then we got the ROBUG components and function explanations. Now, ROBUG stands for robot bug. That's why it's called ROBUG.
Oh,
Yeah. The ROBUGs handle the problem of pollination, pest control, fertilization, and they also manage the pH of the soil. Now, how do they do this? For pollination, these ROBUGs pollinate by imitating how bees pollinate plants. They do that by landing on a plant, storing the pollen in a small compartment under their stomach, and then spreading it. Then for pest control, these ROBUGs act as pest control by eating all the bad pests that enter the dome. Yeah. Then for fertilizers, the ROBUGs fertilize the plants by digesting the bad bug it eats, and also by finding waste to eat around the campus. All this waste then goes inside the stomach of the ROBUG, and then it's turned into fertilizer. The bug then disperses this across the plants. Then finally, the ROBUGs also work as a pH manager. Now how they do this? It's by they do this by having many different minerals inside the robug, such as iron, manganese, and zinc for acidic soils, and phosphorus and calcium for the alkaline soils. Next up, we got benefits to the community.
Hello, new character unlocked. I'm Allie. So the four things that I focused on within like how everything helps like our community at I was gonna say my high school, but Ohlone, it's reliability, and for the first one is being reliable and diverse. So by having these forms of water recycling, we're able to create reliable sources other than like if you say you had groundwater and stuff, like especially since we're in California with droughts and stuff, and so it's like a sure thing. We don't have to worry about like water insecurity. And then the resilience, it helps like our infrastructure from the drought, and in general it allows us to adapt with climate change and like rainfall patterns, water availability. And then healthy and efficient, since we have these forms of technology with the robugs as well as the farm Ferris wheel thing, it allows for more control, accurate data, and precision with the gardening tactics to keep allowing for a growing garden in the best ways. And then it allows for the best quality for the community, like with the food. And then lastly, our environmental sustainability conservation. This relies on our irrigation system. And so with our irrigation, the drip irrigation system, it allows for the plants not to be overwatered or for there to be evaporation because it goes straight into the root, and also reduces like runoff, it protects the land, nearby ecosystems, and minimizes chemical runoff. It also allows for minimizing of strains for like sources like lakes stuff. All right, here are references. Yes, references. Notice the first
Brilliant,
the
by the way.
second.
Yes, and the third. And then thank you so much for listening.
Thank you. We really appreciate it.
And we must. All right. And we must. And it must. You told me to read it. All right, hop in. I'm gonna pass one right here. We're gonna have. Oh my god! Ready. And then I'm gonna bring it over to my friend over here. Woo! Yeah.
Have a great day.
Woo!